14.1 Video 2. We will now walk through a couple of examples of how to carry out the goodness of fit inference procedure. In this first example, we'll be looking at the distributions for the favorable responses of a survey sent out by labor union bargaining agents to its membership. We want to know whether or not the distribution of responses now, or this year, fits well with the distribution of responses from last year, or did it change? Is it different? We took a random sample of 500 employees to do this survey, and we first want to take a look at the table for the distribution, and then we'll come back to actually stating the null and the alternative hypothesis. When the bargaining agents sent out the survey last year for their employees to comment on their priorities for these 5 categories listed right here, they ended up with this distribution for their favorable responses. When they sent out the survey this year for the 500 employees, they observed this kind of distribution right here. So these numbers represent the number of employees who stated their priority or favorable response towards these categories. Now what we want to do is see exactly what we should expect for these 500 employees if things have not changed from last year. So what we do is we multiply this distribution, each category, by 500, and these will be our expected numbers. So over vacation time, we would expect about 20 employees would list that as a favorable response. And for salary, it would have been 325, 65 for safety regulations, 60 for health and retirement, and then 30 for overtime. You can see that these numbers don't quite match up perfectly. We wouldn't expect them to be exactly the same. What we want to know is if at least a couple of these categories have significantly changed. At least 2 of them must be significantly different for us to reject the null hypothesis. These responses, by the way, should add up to 500, just like the observed data here. To begin the inference procedure, our 4 steps for this example, we start out with the null hypothesis. In the null hypothesis, we are going to write distribution of favorable responses fits with expected distribution from last year. The alternative hypothesis basically uses the same words, but it says that the distribution doesn't fit. It has changed. So you'd basically write the sentence over again. Responses does not fit. Oops. With last year's distribution. Now there is an alternative way of saying the null hypothesis. You could simply list all of the proportions of the distributions. So I could say for vacation, proportion should be 4%. For salary, of course you'd have to label each one of these, is 65%, and the proportion for safety regulations is equal to 13%, and we could just list all those proportions in our null. That would be an alternative way to state the null. In step number 2 of the inference procedure, we want to check the conditions for carrying out the chi-square goodness of fit test. And those conditions are that our expected numbers are at least 1, all of them, and these expected numbers also should be at least 5, or most of them should be at least 5. We don't want any more than 20% being less than 5. We do notice that all of these numbers are greater than 1 and greater than 5, so we have met the conditions for carrying out the chi-square goodness of fit test. So in step number 3, we've got to go ahead and calculate the chi-square numbers. And you'll see that we have the formula right up here in our third column of our table. And we go ahead and we take the 30 minus the 20, that gives us 10. And we square that, and we divide that by the 20, and that's how we got this number right here, 5. So we do that for each one of these rows, and these are all of our chi-square numbers that have to be added up to give us the chi-square test statistic. Now we have 5 categories altogether, so that means our degree of freedom is equal to 4. That would go in here for a chi-square CDF. The chi-square test statistic would be right here, and then our right tail upper bound is 99. Remember, the chi-square distribution is right skewed starting at 0, and our chi-square number would be out here somewhere, don't know exactly where. This distribution curve would be based on our DF of 4, and we're trying to figure out this shaded region right here. If you put this into your calculator, you'll find chi-square CDF in the same spot you find normal CDF and TCDF. You will find that the p-value is 0.007. With a p-value that small, we would reject the null hypothesis here. So in our final step, step number 4, we would say that we reject null hypothesis. 0.007 is less than our alpha of 5%. So we have strong evidence that the distribution of favorable responses is different from last year's distribution. Okay, there you have it, the 4-step inference procedure for goodness of fit chi-square. In example number 2 here, we're taking a look at the distribution for household types for a community in Montana, Dove Creek, Montana. We took a sample of 411 households, and we want to see if the distribution of household types is the same as the U.S.'s population. So in this particular example, we're not comparing one time period to another time period to see if things have changed over time, but we're just trying to match up one population with another. You'll notice the table here is all set up for us. We have the distribution for the United States and all the categories for types of households. We've got 5 different categories, and the 411 observations from Dove Creek are listed here, and we want to see if it fits well with the distribution for the United States, so we need to take a look at the expected values. We did that by multiplying each one of these percentages by 411. So we did that for each category, and we did carry it out to 2 decimal places here, and notice that all of these are greater than 5, so they're greater than 1 as well. So it does meet the condition for doing the chi-square goodness of fit. Our null hypothesis in this case would be the distribution of household types for Dove Creek is the same as the United States. Distribution. Okay. Our alternative, again using much the same language, is simply the distribution for Dove Creek household types is not the same as the US's. Okay, and now we need to move on to the next step of the inference procedure. Already noted that the test is the chi-square goodness of fit test, and all conditions have been met. All E numbers are at least 5, which means they're also at least 1. And we would go ahead and figure out the chi-square statistic using our formula. That formula again is observed minus expected squared all over the expected. We would do this for each number. Now at this point I'm going to tell you that you can do this test on your calculator. If you go to the test section in your calculator and find the chi-square goodness of fit in your 84 or 89, you'll see that you have one there, and when you enter that, you'll notice that it has list 1 and list 2 for our observed and our expected. So when you run these tests, you're going to want to put these numbers into list 1 and list 2, and all you'll need to do then is put in the degree of freedom, which was 4 in this case, and hit calculate, and it will give you your chi-square number. So that's what I did. I put all my observed numbers and my expected numbers into my calculator, put degrees of freedom of 4, and hit calculate, and I ended up getting a chi-square number on my calculator equal to 13.02, and it stated that the p-value was equal to 0.01. So now I can make my decision. That decision is that I am going to reject the null. 0.01 is less than 0.05. That was our alpha, and we would have to say that we have strong evidence that the distribution of household types in Dove Creek is not the same as the U.S. distribution. So there you have one more example of how to carry out the chi-square goodness of fit test.